Afternoon, children. Because of sort of problem, class delayed by 5 minutes. You give your attendance there in the comment box. And in last class, we discussed about constructions. Locating the points. In the given Cartesian plane. And now yes, can you hear me clearly? Yes, can you hear me clearly? Better drop a comment there in the comment box so that I come to know that you people can hear me. I can start the class. In last class I said we have started the constructions. Then today we will go for one more topic, that is coordinate geometry. There in coordinate geometry we are again going to discuss about location of the point and then the formulas that we are going to use to find the distance between the any two points, right? Here in the lesson coordinate geometry, you are already familiar with the concepts of presenting the given point on a Cartesian plane, right? Already know that we are going about respect to the coordinates. Here, as already you know, coordinate geometry is basically related to the plotting of the graphs. Here, on your screens, we are having a Cartesian plane which is divided into 4 equal parts. That is, each part we are going to call it as quadrant. Here in your Cartesian plane, you are having totally 4 quadrants. First quadrant, second quadrant, third quadrant, and fourth quadrant. Every time whenever you are having a divide your quadrant, third and fourth with respect to the axis. And in your on your screen, if you observe x dash ox is a x-axis, that horizontal line that we are going to call x dash ox is a x-axis, and vertical line that is y dash is your y-axis. The horizontal line is called x-axis, whereas the axis y dash. The intersection point of x and is called its on that origin with the coordinates. Here how you are going to represent your origin with the coordinates. Here you can write your origin as 0, 0. 0, 0 means here x coordinate is also 0 and y coordinate is also 0. Usually we used to take the intersection of x and y axis at this point, and this one we are going to call as origin, right? And next, whenever a Cartesian plane is given in our general classes, we are having whenever a Cartesian plane is given. For this Cartesian plane, say this is your Cartesian plane, and if you look any 2 points, say this is a point x, y, and another point, say x2, y2, x1, y1 and x2, y2. These are the 2 points, and when you join a line between these 2 points, suppose if you take this as your Cartesian plane, and this is your points x1, y1. In general, I am taking these 2 points, say it as point A and point B. To find the distance between these 2, means the shortest distance between these 2 points, you know, Find distance between these 2 points using the coordinates, using the location of the points, using a formula. That formula we are going to learn as distance formula. That is our distance formula that we are going to use to find. Here on screen, an image is given. How you are going to write this one to get the distance formula? If you observe here, if you come for this graph, here point A is taken and point B is taken, and this is nothing but the distance between the point A and point B. If you represent point A as x1, y1, in general, if you are taking x1, y1 and B as x2, y2, then what should be this distance? To get this distance, a small work that we are going to do is, we are going to draw the perpendicular from B to x-axis and from A to x-axis. We have to draw the perpendicular and then join A to C. This is the first thing that we have to do. The very first thing that we are going to do is we have to draw the perpendiculars from B to x-axis here. B to, if you draw a perpendicular here, and from A to x-axis, again if you draw the perpendicular. After that one, draw AC, another line joining A to C. After joining this one, if you observe here, get a right angle as we have drawn perpendiculars, ABC. Right, in ABC, it is a right angle triangle. Definitely, this will become the hypotenuse. The distance between the 2 points will become your hypotenuse. BC is one of the side and AC is another side. Next, see, this point A and this is point C. What will be the distance BC here? To calculate the distance BC, you have to locate point C such that point C is but x2, y1. This is x2, y1, and to get BC, how you are going to get BC? From B to x-axis, what is the length? The length is y2, right? From C to x-axis, what is the length? It is y1. The total length is, this is the total length, this is y2, and this small difference is y1. If you subtract from B the distance of point C, you will get y2 minus y1. Here you are going to get y2 minus y1. Here, to get it more clear, better take here this one. Suppose in a Cartesian plane, if this is your distance, say it as A and B. And this is x1, right? Here, this is your y-axis and this is your x-axis. Then always x1 represents, or the x represents the distance from the y-axis. Suppose this is your point A. x1 is always representing the distance of that point from y-axis, whereas y1 is going to represent, or y is going to represent the distance of that point from x-axis. This is a normal thing, and we are going to call it as Einstein ordinate. Distance from the y-axis nothing but x coordinate, whereas you can write here distance from y-axis is always represented by x coordinate. That is nothing but abscissa. and distance from x axis, that is represented by y coordinate, that we call as ordinate. The distance from x axis of that point is called ordinate, whereas distance from y-axis, that is represented by x coordinate, and it is called abscissa. You are going to call it as abscissa. Right? Now, here, to get more clear, what is the distance of a point B from x-axis? How you are going to represent it? Suppose this is your point B. What is the distance of a point from x-axis? Is represented by this is the distance, and it is represented by y2. And if it is point A, the distance of point A from x-axis, it is represented by y1. Here, if I draw a perpendicular to make a triangle, now the total distance of a point B from x-axis is y2, whereas y1 is the distance of a point A from x-axis. This is the total distance. To just get BC, here BC means actual distance is y2. In that one, y1 is opposite side of the parallelogram. Then only this, if you name it as D and E for our convenience better. BD is y2, but what will be CD? CD will be just y1. To get BC, what I can do? y2 minus y1 I can do. Isn't it? Now similarly, just I will remove this. What is the distance? Next, what is AC? To get AC, see here. What is the distance of B from y-axis? It is x2. What is means here? If this is your origin, OD will be x2. And next, what is the distance of A from y-axis? It is given by the x coordinate, that is x1. Means OE is x1 and OD is x2. To get ED, what I have to do? x2 minus x1 I have to do. And ED is opposite side of AC. As it's a rectangle, opposite sides will be equal. AC will be x2 minus x1, BC will be y2 minus y1. Now, if you see this ABC here in the figure, this is similar one. In the figure, ABC, it is 90 degree. Then according to Pythagoras theorem, I can apply Pythagoras theorem here. By Pythagoras theorem, what we can write is by Pythagoras theorem, we can write AB square is equal to AC square plus BC square. AB square is nothing but the distance we have taken, that is hypotenuse. D square is equal to AC. AC means just now we have calculated it as x1 whole square plus BC. Plus BC means we have taken y2 minus y1. Then to get D, taking square root on both sides, because it is D square, to make it free we will take square root on both sides. D is equal to root of x2 minus x1 whole square plus y2 minus y1 whole square. This is nothing but your distance formula. Right? This formula we are going to use for many of the problems to solve. Right? Here in distance formula, how we are going to apply this distance formula? Here distance formula is nothing but d is equal to root of x2 minus x1 whole square plus y2 minus y1 whole square. This is your first formula that you are going to use in solving coordinate geometry. Here in coordinate geometry, again just one example we will discuss. Do points here in distance formula, this distance formula we are going to use to find the distance between any two points. Suppose this is a point here, say A and B or C. To find this distance, we are going to find the distance formula where coordinates are given x1, y1 and x2, y2 in general. Then the formula will be distance is equal to root of x2 minus x1 whole square plus y2 minus y1 whole square. This is your distance formula that you are going to use. Next, similarly, we have a question here. In this question, the question is, do the points 3, 2, minus 2, minus 3 and 2, 3 form a triangle? If so, name the points. This is your given question. They are asking, there are 3 points. Say this as 3, 2, minus 2, minus 3 and one more is 2, 3. Do the points 3, 2, minus 2, minus 3 and 2, 3 form a triangle? If so, name the type of the triangle. For this question, what is the first condition? The first condition for a triangle to be, for the 3 points to be triangle is, what is the condition? Suppose we are given with 3 points, say A, B and C. A, B and C. These 3 points are going to be triangles only if when AB plus AC should be greater than BC. This is the condition. The sum of two sides should be greater than the third side. All we know that, right? Here the points are given. Your work is you have to first find the distance between the points. If I take this as the first point, say A, B and C. To find the distance between AB. If we take AB, what are the points here? Minus 2, minus 3 and 3, 2. According to the formula, we are having the distance between the AB, that is D is equal to root of, better name them, x1, y1, x2, y2. To make it easier, just substitute x2 minus x1 whole square plus y2 minus y1 whole square. Now this is your regular formula. After this one, just substitute here only, root of x2 means 3 minus x1 is minus 2, better write once again bracket whole square plus y2 2 minus x y1 is minus 3. Put the bracket to make it more clear. Next is bracket 3 minus 2 whole square. Minus of minus will become plus 2 whole square plus 2 into minus of minus plus 3 whole square. Now you got 5 square plus 5 square, that is nothing but 25 plus 25. 5. That is nothing but 2 times of, or we can write 5 times of root 2, means 25 plus 25 is root 50. Root 50 I can write it as in a perfect square form. 25 twos are, for that 25 twos I can take 5 outside, it will be 5 root 2 square units. This is first distance. Next one, if you go for next one more, here it is. If I take AC is equal to root of x2, I will take this time x2 means x1, y1 we will take same, x2, y2 we will take 2 and 3. This one we will take as 2 and 3. x2, y2. Then here if you substitute, you will get 2 minus of minus 2 whole square plus 3 minus of minus 3 whole square. Then if you solve, you will get 2 minus of minus will become plus whole square plus 3 plus minus of minus. Then 4 square plus 6 square, that is nothing but 16 plus 36. Is it right? 16 plus 36 means it is, you are going to get 52. 16 plus 36 is 52. That is, you are going to add here 16 plus 36, that is 12 and 52. Now we got the length AC as 52. Then similarly we can go for BC. Again for BC, I can directly apply. This time 3, 2 I will take as x1, y1. This one I will take as x1, y1. Here 2 minus 3 whole square plus 3 minus 2 whole square. Each and every time you should remember the formula here. 2 minus 3 is minus 1 whole square plus 1 whole square. You are going to get 1 plus 1, that is nothing but root 2. Now here you got all the 3 sides. The first side is here 5 root 5, side AB. Second is root 52, that is AC, and root 2. Isn't it? This is about the how to get the sides of a triangle. Now next work is we have to name which type of triangle it is. Which type of triangle it is means how you are going to name it as. Here how you are going to name this triangle. It's very important while naming the triangles. Here as you see, all the triangles which you have solved, all the sides that you have got here are different, right? All the sides are different means which type of triangle it is. See, one was root 50, another was 52, another was root 2, right? Then is it a triangle? Yes. As I said, the condition for triangle, that is the sum of 2 sides should be greater than the third side. That condition is satisfying here, therefore it is a triangle. But it can be any triangle. Then which type of triangle it is? If you see the points, And if you see the condition of Pythagoras theorem, P, that square on the hypotenuse will be equal to the sum of the squares on other two sides. If you apply that condition, you are going to get the result, same result, isn't it? That means you are going to get it as a right angle triangle. It is a right angle triangle. How you are going to show it as a right angle triangle here? Yes, this is your question. How you are going to show it as right angle triangle? Here AB is root 50, BC is root 52, and I think AC is root 52 and BC is root 2. How you are going to show it as a right angle triangle, or how you are going to represent? As I said, first it should be a triangle. It is a triangle. Yes, because AB plus AC is greater than BC. You can take any other condition. AC plus BC is also greater than AB. If this condition is satisfied by any three given points which are to be triangles, then definitely this condition should satisfy, that sum of two sides should be greater than the third side. This condition is satisfying. Yes, ABC is a triangle. Then which type of triangle it is? To name. We are going to name it. See here, if you take AB square plus BC square is equal to AC square. Just substitute root 50 whole square plus root 2 whole square is equal to AC square. How much we will get? Just check. Root and square will get cancelled. Get 50 plus 2. 50 plus 2 is 52. And this is nothing but your AC square. Then if you take out the square root, you will get root 52. Means what? Here the sum of the squares on two sides is equal to the square on the hypotenuse. That is your Pythagoras theorem. Therefore, what we can write? Therefore, triangle ABC must be a right angle triangle. Right angled triangle. Is it clear? Here by doing only you can get the idea whether it is a right angle triangle or not, whether it is isosceles or not. If it is isosceles, definitely the two sides, any two sides will be equal and third side will be unequal. If it was the equilateral triangle, then all the three sides will be of different length. Sorry, if it is an equilateral triangle, all the three sides will be are of same length. If it is a scale line, all the three sides will be of different length. And if it is a scale line, then based on the property which the sides are exhibiting, we can name it as a right angle triangle. Right? We will see one more question here. In the question, it is given, show that the points 1, 7, if you see, here it is 1, 7, 4, 2, minus 1, minus 1, minus 4, 4 are the vertices of a square. Especially while dealing with coordinate geometry, when you are deciding about the shape of the given figure, it's very important to check all the properties. Here, as they are asking us to show the points are squares, means what is the first condition for a figure to be a square? All its sides should be equal. This is first condition. Next one is diagonal should be equal. Length of the diagonal should be equal. Whenever you are checking for any of the conditions of the figures, your first work is you have to check the lengths of the sides as well as lengths of the diagonals. Here, if you see the solution, see here, A is, better name the points as it is given. A square means 4 points should be there. A 1, 7, B 4, 2, C minus 1, minus 1, D minus 4, 4. AB, if I take the length of AB, 4 minus 1, x2 minus x1 whole square plus 2 minus 7 whole square is equal to 3. 4 minus 1 means 3 square plus 2 minus 7 means 5 square. 9 plus 25. The first length is 34. Similarly, if you go for BC, minus 1 minus 4 whole square plus minus 1 minus 2 whole square is equal to minus 1 minus 4, two same signs, add the number, minus 5 whole square. Minus 1 minus 2 means two same signs, add the number, minus 3 whole square. Lastly, you will get root of minus 5 whole square means 25 plus 9. That is again 34. Next, you have to go for CD. Here, point CD. In the point CD, if you see here, here in the CD, you are having CD is equal to root of minus 1 minus of minus 1, because it is coordinate is negative here, minus 4 minus of minus 1 whole square plus 4 minus minus 1 whole square. If you solve it, root of minus 4 plus 1, because minus into minus is plus, minus 4 plus 1 whole square plus 4 plus 1 whole square. If you solve, you will get minus 3 whole square plus 5 square. That is 9 plus 25 is again 34. CD also we got 34. Now last one is DA. Here in the DA, root of minus 1 D and A. 1 minus minus 4 whole square, x2 minus x1 we have taken. 1 minus of minus 4 whole square plus 7 minus 4 whole square. Right? Minus of minus will become plus here. 1 plus 4 whole square plus 7 minus 4 is 3. 5 square plus 3 square. Then 25 plus 9 is 34. Again we got the fourth side as also 34, but your work will not complete here. If just you got all sides are equal. Means it need not be square only, it can be rhombus. So to prove it as a square only, you have to go for proving the lengths of the diagonals. Right? If you take the diagonal AC, here it is. If you take the diagonal of AC again you have to mark as x1 y1, x2 y2, then AC is equal to, if you come here for AC, minus 1 whole square plus minus 1 minus 7 whole square. Minus 1, two same signs, add the number, minus 2 whole square plus minus 8 whole square. That is nothing but 4 plus 64. That is root 68. Right? Then BD. Whole square. 4 plus 4, that is nothing but root 68. Now we got these as your diagonals equal, and all the three sides are equal. Root 34, it is root, also it is root 34, and here also it is root 34. All sides are equal as well as diagonals are equal. So with all these properties, this given 4 points, that is quadrilateral, we can name it as it is a square. That the given quadrilateral is a square as all its sides are equal and all its diagonals are equal. This is about your how to apply your distance formula in calculate distance of the or your or the position is all about this coordinate geometry. How to justify the given field based on its properties, right? Your work is just go questions and as much as possible. In next class, we will discuss in detail regarding the and one more thing, try to solve the questions which are appeared in the previous examinations based on this coordinate geometry, right? Till then, stay home and stay safe. We will discuss in next class, the next part. Thank you.